At the edge of our known planetary realm lies a world bathed in shadow, a place of ancient ice and celestial secrets beyond the calm blue orbits of the gas giants. For decades, Neptune was considered the solar system's final planet, its slow journey around the sun marking a kind of cosmic boundary. But that assumption was wrong. What lies beyond Neptune is more than just empty space. It's a gateway to a region as enigmatic as the deep ocean, filled with frozen relics of planetary formation, and perhaps something else. Something massive. Something that could change everything we thought we knew about the solar system. In the mid-20th century, astronomers began to suspect that Pluto was not alone. It was far too small to account for the gravitational anomalies observed in the outer solar system. In fact, its orbit was eccentric and inclined, unlike those of the 8 planets. This led to the proposal of a belt, a vast region of small icy bodies beyond Neptune, first hypothesized by Gerard Kuiper and Kenneth Edgeworth. Decades later, this theory became reality. Today we call it the Kuiper Belt. NASA has confirmed that the Kuiper Belt begins roughly at 30 astronomical units from the Sun and stretches out past 50 AU. It is home to tens of thousands of icy bodies, larger than 100 kilometers, and millions of smaller ones, remnants of a time when the solar system was young and chaotic. These objects are thought to be composed of frozen water, methane, ammonia, and silicate rock. They are time capsules, preserving the solar system's ancient chemistry, untouched, unheated, and unsullied for billions of years. Among these icy denizens are Pluto, Eris, Haumea, and Makemake, dwarf planets that orbit the Sun in long, cold cycles. They are classified as trans-Neptunian objects, or TNOs, a term that has come to define a wide family of distant bodies. In 1992, astronomers David Jewett and Jane Liu discovered 1992 QB1, the first TNO found after Pluto. Since then, over 5,000 have been catalogued. Observations from the Hubble Space Telescope, the Dark Energy Survey, and the Subaru Telescope in Hawaii have revealed hundreds more, each with its own mysterious orbit and surface composition. But beyond even the Kuiper Belt, there lies something stranger, a region known as the scattered disk. Here orbits are wildly elongated and tilted, suggesting past gravitational interactions with Neptune, or perhaps something else. Some objects like Eris, Sedna, and 2012 VP-113 move on paths so distant and detached that Neptune's gravity cannot be the sole explanation for their trajectories. Sedna, for example, reaches out to nearly 1,000 AU from the Sun, in a single orbit that takes more than 11,000 years to complete. It never comes close enough to be significantly influenced by any known planet. Astronomers began to notice a pattern. Several of these extreme trans-Neptunian objects, or ETNOs, seem to cluster together. Their orbits pointed in the same direction, their perihelia aligned as if guided by an unseen force. This wasn't likely to be a coincidence. In 2016, researchers Konstantin Batygin and Mike Brown of Caltech proposed a bold idea. There might be another planet, massive, distant, and completely undetected, lurking in the outer solar system. They called it Planet 9. According to their calculations, Planet 9 would be 5 to 10 times the mass of Earth, orbiting the Sun at a distance between 400 and 800 AU, on an elongated, tilted orbit that takes 10,000 to 20,000 years to complete. Its gravitational influence, though subtle at such distances, could explain the orbital alignment of ETNOs and the strange behavior of scattered disk objects. But if it exists, why haven't we seen it? One reason may be sheer distance and darkness. A planet that far away would reflect very little sunlight. It would be thousands of times fainter than Pluto. Another factor is sky coverage. Planet 9, if it exists, may be hiding in a dense star field in the Milky Way's plane, or in a part of the sky not thoroughly surveyed by existing telescopes. Infrared sky surveys like WISE have placed constraints on its possible location and temperature, but haven't ruled it out. Adding to the mystery are objects like Niku, a TNO with a retrograde, highly inclined orbit that defies standard models. Its very existence hints at a past solar system far more dynamic and violent than we imagine, possibly shaped by a rogue planet or interactions with passing stars in the Sun's birth cluster. Then there's Arakoth, the contact binary explored by NASA's New Horizons in 2019. Its peanut-shaped body and gently merged lobes suggest an environment of extreme calm and low velocity, another clue to the early solar system's conditions. Further out still lies the Oort cloud. Though never directly observed, this vast spherical shell is believed to encircle the solar system at distances up to 100,000 AU, containing billions of icy bodies that occasionally fall inward as long-period comets. If real, the Oort cloud represents the frozen edge of the Sun's influence, and possibly the place where interstellar and solar material first intertwined. Voyager 1, now over 160 AU away, is expected to reach its inner boundaries in a few hundred years. What's truly astonishing is how little we still know about this distant frontier. With the help of telescopes like JWST and the upcoming Vera Rubin Observatory in Chile, astronomers hope to detect faint movements of distant objects over time. The Large Synoptic Survey Telescope will scan the entire visible sky repeatedly, improving our odds of spotting the subtle drift of Planet 9, or anything else lurking in the deep. Some scientists remain skeptical. Could the strange orbits be due to observational bias? Could galactic tides or dark matter filaments subtly affect these bodies? Others propose modified gravity theories like MOND that challenge Newtonian assumptions at the scale of interstellar space. But as more ETNOs are discovered with increasingly odd orbits, the case for Planet 9 strengthens. Discoveries like 2015 RR245, orbiting the Sun every 700 years in a 9.2 resonance with Neptune, suggest unseen gravitational shepherding. These resonances are not random. They speak of structure, of orchestration. Some believe that a massive planet on the outskirts is organizing these objects into their current configurations, much like Jupiter shaped the asteroid belt. Yet perhaps the most exciting implication of Planet 9 is not just gravitational. It's chemical. A large icy planet in the extreme cold of deep space could retain a thick atmosphere of hydrogen, helium, and methane. If its core is warm as models predict, it could even host a subsurface ocean beneath a frozen shell. Life in some form could theoretically emerge in such an environment. Not life as we know it, but life as it could be, alien extremophilic adapted to the void. NASA's theoretical models suggest that if Planet 9 exists, it may have formed closer to the Sun and was ejected outward in the early days of the solar system, perhaps during a chaotic period of planetary migration. Alternatively, it could be a captured rogue planet, wandering interstellar space until caught in the Sun's gravitational pull. Both scenarios raise profound questions about how common such ejections and captures are in other planetary systems. If we find it, if we photograph a distant, slowly moving point of light and confirm its orbit, it will be the most significant planetary discovery in a century. It will rewrite our textbooks, redraw our solar system, and perhaps redefine what it means to be a planet. More importantly, it will confirm that the universe still holds surprises, even within our own cosmic neighborhood. The region beyond Neptune is no longer empty. It is alive with motion, with invisible dances choreographed by ancient gravitational pulls. Each icy body tells a story of formation, migration, collision, and survival. And somewhere out there in the cold, dark silence, something massive may be waiting for us to find it. As our telescopes peer deeper and our models grow more precise, we stand on the edge of discovery. The edge of everything we know and everything we have yet to understand. Beyond Neptune lies not just the forgotten corners of our solar system, but perhaps the key to unlocking how all of it began, and perhaps how it might end.